Okay, we're going to take a look at worksheet 21, which is the review for the chapter test. This is a long worksheet, so instead of having one long video, I'm going to break it down into several short videos so that you don't have to watch the whole thing at one time or don't feel like you need to be chained to your computer for a couple of hours. Okay, let's take a look at the first question. It says solve the following equations by the square root method. Solve for all solutions including imaginary. So the square root method means that there isn't going to be a b term. There's just going to be ax squared plus c equals 0. So let's get all of the terms on one side and see what we have. I will have, when I subtract the 11x squared from both sides, I'm going to have negative 3x squared minus 70 equals 5. And if you want, you can subtract the 5. I just want to show you the format you will see these in. Okay, so when you see a quadratic of this form, ax squared plus c, then that's going to be the square root method. To solve this, you isolate the term with the variable, minus 3x squared, which means you're going to add 75 to both sides. Divide both sides by negative 3. So x squared is equal to negative 25. And then x is equal to plus or minus the square root of negative 5. So x is equal to plus or minus I root 5. Okay, next one, b. I want to again isolate the term that has the variable in it. So 9x squared is equal to 13. Divide both sides by 9. So I have x squared is equal to 13 over 9. Take the square root of both sides. X is equal to plus or minus the square root of 13 over 9. Remember, that's the same as saying x is equal to plus or minus the square root of 13 over the square root of 9. 9's a perfect square, so I get x is equal to plus or minus the square root of 13 over 3. Number 2 asks us to solve the quadratic equation by factoring. Remember, in factoring, the first thing you want to do is look for the greatest common factor. So in A, I can factor out a 4. That's going to give me x squared plus 4x plus 3 equals 0. Then you ask the question, what two numbers multiply to give me a 3, but add to give me a 4? So 3 times 1 and 3 plus 1. So that means I have 4 times x plus 3, x plus 1 equals 0. It says solve, so that means I have to use the zero product property. If a times b is equal to 0, then either a is equal to 0 or b is equal to 0. So if we treat x plus 3 like it were a, when will that be equal to 0? When x is equal to negative 3. If you treat x plus 1 as b, then when x plus 1 is equal to 0, when x is equal to negative 1. So those are the two solutions to that quadratic equation. B does not have a greatest common factor. Remember, we can use our calculator for these. We're going to take the product of A and C. So what multiplies to give me 24, but when I add them together, I get a negative 10. So what two numbers multiply to give me 24, but add together to give me negative 10? That's going to be minus 6 minus 4. Remember, that means that minus 6x minus 4x equals negative 10x. So that means wherever I see this negative 10x right here, I'm going to take the negative 10x out, and I'm going to replace it with this equivalent expression. So I have 3x squared minus 6x minus 4x plus 8 equals 0. Group the first two terms, group the last two terms. Remember, if the operation between them is negative, you must change the sign on that last term. So now look at this first group. Factor out the greatest common factor, which will be 3x. That will leave you x minus 2. Look at this second grouping. Factor out a 4. That will leave you with x minus 2. At this point, you should have a common binomial, x minus 2 in each of those terms. Factor out the x minus 2. What's left is 3x minus 4 equals 0. Again, the zero product property, treat this as if it's A. So when will x minus 2 equal 0? When x is equal to 2. Treat this 3x minus 4 as B. When will 3x minus 4 equal 0? When x is equal to 4/3. So the solutions are x is equal to 4/3 and 2. C, again, when you look at this, you have x squared minus 64. That looks like the difference of two squares. For this one, you could use the square root method or the difference of two squares. Either one, you'll get the same answer. You're asked to factor this one, so you should recognize this factors to x plus 8, x minus 8 equals 0. So when x is equal to negative 8 and 8 are the solutions. You can say when will x plus 8 equal 0, when will x minus 8 equal 0, and that will give you those answers. Let's take a look at number 3. It says graph the following, show 5 plotted points. Okay, when you look at the first one, you can think about this in a couple of ways. You can think about the axis of symmetry and where is the vertex, or you can think about transformations and how does this shift about the coordinate plane. I think we'll look at the axis of symmetry first. Remember, that is minus b over 2a. In this case, b is 0 over 2 times negative 2, which is 0. So that means my axis of symmetry is right here at x equals 0. Then I need to find my vertex. Remember, the x-coordinate of the vertex is the same value as the axis of symmetry. To find the y-coordinate, I will substitute a 0 in for x. So here, y is equal to 3. So the vertex is at 0, 3. So I'll plot a point at 0, 3. As I'm looking at the equation, because this is negative, I know it opens down. Okay, and then I want to find the x-intercepts. Because it's in the form of y is equal to negative 2x squared plus 3, the x-intercepts occur when y is equal to 0. So I'll substitute a 0 in for y. And then solve this for x by subtracting 3 from both sides, dividing both sides by 2, by -2, sorry. So I have 3/2 is equal to x squared. So x is equal to plus or minus the square root of 3/2. And you can get an approximate decimal representation for that at this point. So we can kind of graph that. This should be, remember we have to rationalize the denominator. We haven't done a lot of that. But that would be, I have plus or minus the square root of 3 over the square root of 2. So I'm going to multiply numerator and denominator by root 2. That's going to give me plus or minus the square root of 6 over 2. So those will be my x-intercepts. Let me scroll back up. And graph these points. So I have the x-intercepts at plus and minus the square root of 6 over 2. And I said go ahead and get a decimal approximation for this. We'll go ahead and put those on and graph that parabola. Now B is in vertex form, so that makes it fairly easy. You know that the axis of symmetry is also the x-coordinate of the vertex. Oops. The vertex is at 3, -4, so the axis of symmetry is at 3. Vertex is at 3, -4. Then we want to find the y-intercept. Remember, we find the y-intercept when x is equal to 0. So y is equal to 0 minus 3 squared minus 4. So that's going to be -3 squared, which is 9, minus 4, which gives us a y-intercept at 5. So that will be at 0, 5. Remember, it has a corresponding point on the opposite side of the axis of symmetry at the same height. So 3 units away. So I have my vertex at 3, -4. I have my y-intercept at 0, 5. I have the corresponding point at 6, 5. So there's 3 of my points. Now I have to only find the x-intercept. So I'm going to find the x-intercept. Remember, that's when y is equal to 0. So here 0 is equal to x minus 3 squared minus 4. Solve this for x. So I'll add the 4 to both sides. Take the square root of both sides. So I have plus or minus 2 is equal to x minus 3. Add the 3 to both sides. So 3 plus or minus 2 is equal to x. So that means x is equal to 3 minus 2, 1. And x is equal to 3 plus 2, which is 5. So let's go back up and put those intercepts. So I have an intercept at 1, 0 and 5, 0. And when I graph that, it should look symmetric about that axis of symmetry. So that is questions 1, 2, and 3 for the chapter test, which is coming up this week. Hope that helps. There'll be another video with the next set of questions it will be worksheet 21B video. Thank you.